Okay, so this is a lab rubric for the conservation of energy, and there's a sample lab report. So let's take a look compared to the rubric. So we have the student name and the lab partners and the date. These are all good. The title's in there. There's purpose, procedure, conclusion, and there's also a question section that I used to have. And there's data, I suppose data and analysis. So the sections are all there. Let's take a look at the purpose. Experiment to help understand the concept of work, energy, and conservation of energy. Okay, it's all right. It's not really the best. We're trying to prove energy is conserved by comparing potential energy and kinetic energy. So this is not exactly hitting that point. And for let's see, for valid purpose, I might take half a point off because it's not really exactly what I was looking for. So for procedure, let's see, end of air track, contraption was placed. Okay. Mm, attach the glider, freely off the table. Um, the glider's weighed. Okay, so turn down, no friction. Um, 10 gram weight placed, and then repeated until 120 grams. And in some of the later labs, I started using 150 grams as maximum. All right, photo gauge. Okay, so let's keep looking down. The procedure, I just read it. I thought it was detailed enough. And okay, so let's look at the conclusion. After taking all the data put together in a table, slope-intercept equation taken, potential energy calculated two ways. First way to find the area of each trapezoid, and was this. So this is too much for conclusion. This should be in the data and analysis. I won't take points off, but I'll remind the student the conclusion should be short, should be reflecting the purpose. So the second way of using this formula, you got that number, a percent difference with this. Um, okay, well, what about the kinetic energy? So this is kinetic. 217, potential is 225 or 227. So definitely this 102 is not from anywhere. If you try to compare any of these numbers, there's not going to be a 0.02% of difference. So this was done incorrectly. With the velocity was okay. So that 0.08% difference from the original calculated potential energy. So that means less than 0.1%. I do not believe that. 217, 225, or 227. That's more than that. I can see about 5%, not that. The real uncertainty is 5%. So I get a little wary about these values, so I'll have to check their spreadsheet to see how they calculated them. So let's check against the rubric. So kinetic energy, they did that. They did potential energy, they did those, right? So let's check. Relative difference between potential energy with trapezoidal rule and the kinetic energy. They did not do that right. And relative uncertainty, such a small value, I do not believe that. So this was done incorrectly. So find all of these, and I'll assume that they did the trapezoidal rule correctly. I'll take a half point off. And it was saying that uncertainty, the conservation of energy was proven. At least well, according to their calculation, they did. So I would be okay with that. And let's take a look at data. So weight versus stretch rubber band in meters, newtons. This looks decent. And masses and their corresponding weights. These are the positions. These are the stretches. Okay, so the decimals are all acceptable. This is okay, one too many, but let's compound that together with these. The sum, there's definitely too many digits for the area. We're looking at areas calculated from the weight and the stretch. The stretch only has two decimals. If you keep the two significant figures. If you keep 3, then you have 3. So the sum should also have only 3. So too many, and the kinetic energy also too many. 5 decimals, 1 out of 100,000. That's impossible. And the percent difference was calculated incorrectly. And kinetic energy, well, that's potential. Sorry, kinetic. They both have too many decimals. This definitely is wrong. Relative uncertainty. If I trust that, it's I'll take a whole point of all these various digits that are too many, and also the relative error was calculated incorrectly, so they drew the wrong conclusion according to that relative error. So all together, I think is roughly a 13 out of 15 points. And I will also mention to students to move the discussion inside of conclusion into the data analysis, and also move data analysis up before the conclusion, because that's what naturally feels like you have the flow of how you would set up your experiment, what are your results, how you analyze your results, and then you can draw your conclusion. So all together, if I did take some points off the formatting, I would take a point off the formatting and tell the students to reorganize the order of your data, and also move part of the analysis to the data analysis. But I'd say either a 12 point or 13 points will be a decent grade for this report.